This will cover section 6.7, which will wrap up our discussion on factoring. So far we've talked about factoring when there's 4 terms, when there's 3 terms, and when there's 2 terms. And the 3 terms, or the trinomials, always had the highest exponent of 2. For example, like this first one where we did the tic-tac-toe factoring. If we were going to do that right now, we would take out the greatest common factor, and we'd be left with x squared minus 7x plus 10. Then we would set up our tic-tac-toe, A times C. We would find the factors of A times C that add up to B. Greatest common factor of the corners. Multiply up and across. And then we end up with x minus 2, x minus 5, and bring down that negative 4. That's what we did in the last section. Now, sometimes if we look at that, our exponent is higher than 2. For this next one over here, that just means we have a greatest common factor with an x, because all the terms have an x. So if I take 2x out of this one, 10 divided by 2 is 5, x cubed divided by x is 2 squared. 28 divided by 2 is 14, and 6 divided by 2 is 3. Now, if I were to tic-tac-toe this, I would do A times C. Factors of negative 15 that add up to 14. Greatest common factor, multiply up, multiply across, and I get 5x minus 1, x plus 3, bring down our greatest common factor. That's the same thing we've been doing. But what happens if you can't just take out a greatest common factor and get down to what you're looking for? Then you need to analyze them and see if you can make it look like one of the ones we've been working with. So if we start with this one right here, x to the 4th minus 16, it has 2 terms. So the ones we know with 2 terms were the difference of squares and then the sum and difference of cubes. Well, if we look at 16, 16 is a perfect square, not a cube. So let's think about x to the 4th. X to the 4th could be x squared times x squared. If I put those together, that's 2 x's, that makes 4. So x to the 4th can be rewritten as x squared squared. So we can do the difference of squares with that. We can say the square root of this side would make ax squared. The square root of this side would make b 4. And then I can write x squared plus 4, x squared minus 4. Now, because we started with a number that was higher than the squared, Shadow! Sorry about that. Because we started with a number that was higher than the squared, we want to check our other ones to see if they can keep factoring. X squared plus 4 is not a difference. There's no minus, so we can't subtract that one. We can't do difference of squares because there's no minus. If we look at this one, x squared minus 4, we have the difference of squares all over again. So we're going to continue. The square root of x square root of x squared is x. Square root of 4 is 2. So we have an x plus 2 and an x minus 2. Then bring down the part that we couldn't reduce any further. And now we've factored it completely. So you always want to keep going as far as you can. Now look at this one. This one has 3 terms, so we don't know of any special ones. But one thing I want to point out is this exponent is 4, and the middle exponent is half of that. 4 divided by 2 is 2. That means we can tic-tac-toe this. So let's start that process. Start tic-tac-toeing. A would be 1, B would be 5, A times C would be 4. Factors of 4 that add up to 5. Greatest common factor. Multiply up and across. And then we circle. So we have x plus 4 and x plus 1. The difference here is we started with x to the 4th and x squared in the middle. So this is going to become squared down here in our parentheses. remember, if it was written like this, we would have written y plus 4 and y plus 1, because here there's just a y. So in our problem, we're going to do the same thing. We just turn it into squared, and I'm going to change the letter because that's what's up there, and squared's there. Then we look at these and we say, hey, y squared plus 4 can't go any further, and y squared plus 1 can't go any further, so this one's as far as it can get. Here's a couple more. Try them if you feel comfortable. If not, watch and see how we do. So this one, we have a 4th and a 2. So if I were to tic-tac-toe this, and we have a 4th here, which is like a squared. So let's try. I'm going to try something. And we're going to say 1, 2, 1 times 1 is 1. The factors of 1 are 1 and 1. So these are all going to be 1s. And when I write them, I get x plus 1 for both of them, which is how I would do it. Now here, the difference is, this is x to the 4th, and then the middle is x squared. So we know the x part is going to become a squared. The other thing is, the other part's y instead of a number. So instead of 1, this is going to become a y. Now, this is a little weird because there's the 2 letters. So a way I could check my work is to FOIL. First times first, outside times outside, inside times inside, last times last. And I notice that was a 4 as well. So these should also be squared. And if I square those, now I get my original. So noticing that these are exactly the same, you may have guessed from the beginning that you could have just said, hey, the square root of x to the 4th is x squared. The square root of y to the 4th is y squared. So we're going to do x squared plus y squared, and then 2 of them. So these answers are the same answer. It was a perfect square trinomial. I won't be giving you ones with 2 letters that are super complicated. I just wanted you to be aware. So now this one is similar to this one up here with the x to the 4th, except both terms are to the 4th. So that tells us we may have to keep going. So if we start, a would end up being r squared, and b would end up being t squared. T squared. So I would write r squared plus t squared and r squared minus t squared. Now the first one has a plus, so that's as far as we go. The second one has a minus though, so we have another difference of squares. So a would be r, b would be t, so we have r plus t, r minus t, and then bring this one down, and now we have factored completely. Any of these things can be combined. You might do a factor by grouping, which then turns up having a difference of squares in it. You might end up with a cube, and then once you do the cube, you get something else. So you always want to keep checking until you can't go any further. The last thing is we're going to see the word solve sometimes. When do I know the difference between solving and just factoring? Well, it might say solve. Or if, like this one, the equation says equals 0. That's your hint to solve. Or maybe you have one like this that is an equation. So you're going to get everything on one side so that it equals 0. Then you factor and keep going from there. So let me show you one. If I do this first one, greatest common factor is x. So I'm left with x squared minus x minus 6 equals 0. I'm going to tic-tac-toe the trinomial. 1, negative 1, negative 6. So that would be negative 3 and 2. 1 is the greatest common factor. Multiply up, multiply across. So we get x plus 2 and x minus 3. Bring down our greatest common factor. Now this equals 0. We've factored it. To solve, we take each piece and make it equal to 0. Because if you think about it, if A times B times C equals 0, one of them has to be 0. Doesn't matter what the other two are. If one is 0, they're going to equal 0 when you multiply. So we're going to take that same concept and we're going to say x equals 0. Then we're going to take this one and say x plus 2 equals 0. Subtract 2 from both sides, and we get x equals negative 2. Then we take the last one, x minus 3 equals 0. Add 3 to both sides, and we get x equals 3. Those are our 3 solutions. That means if we were to graph this, those would be the x-intercepts. If I plugged any of those 3 into the original equation for x, it would end up equaling 0. So we're going to do the same thing over here. First, we need to get the 6x squared on the other side so that it equals 0. So we have 4x to the 4th plus 10x cubed minus 6x squared equals 0. Now we want to take out our greatest common factor. So we would have 2x squared plus 5x minus 3. We're going to tic-tac-toe this part. 2, 5, negative 3. Nope, negative 6 because we do a times b, a times c, and 2 times 3 is 6. Factors of negative 6 that add up to 5. Greatest common factor of 2 and negative 1. Multiply up, multiply across. We get 2x minus 1 and x plus 3. I don't know why this is having issues today. We get x plus 3. Bring down our greatest common factor. Make these equal 0. Now we do it to each piece. So we would say 2x squared equals 0. Divide both sides by 2, and we get x squared equals 0. To undo a squared, we take the square root. So the square root of x squared is x, and the square root of 0 is 0. Now, if that were, say, x squared equals 9, when we take the square root, we would get positive 3 and negative 3, because 3 times 3 equals 9, and negative 3 times negative 3 equals 9. So technically, we would have two answers, positive 0 and negative 0. But they're the same number. Here, we're going to do 2x minus 1 equals 0. Add 1 to both sides, and we get 2x equals 1. Divide both sides by 2. We get x equals 1/2. Last, x plus 3 equals 0. Subtract 3 from both sides, x equals negative 3. Now we have all of our answers. So I have one more in here. First thing I'm going to do is I'm going to take out my greatest common factor. So I would get x times x to the 4th minus 81. X to the 4th is like saying x squared squared, and then 89 or 81 is 9 squared. So I could rewrite this as x squared plus 9 and x squared minus 9. Now, x squared minus 9 can break into x and 3. So if I were to write this, I would get x times x squared plus 9, x plus 3, x minus 3. So I greatest common factor. Then I did difference of squares. Then I did difference of squares again. Now I have all of these parts that I'm going to make equal 0. So the first one, x equals 0. The second one, x squared plus 9 equals 0. If I subtract 9 from both sides, I would get x squared equals negative 9. And up to this point, we can't take the square root of a negative, so we could just stop there. You are going to see in the future that you would get something called a complex number. For this section, you just have to say, hey, we can't do it. No solution here. Then we do x plus 3 equals 0. Subtract 3 from both sides. And x minus 3 equals 0. And that gives us positive 3. So our solutions are 0, negative 3, and 3. And because of this 2, if we put those together, we would have 1, 2, 3, 4, 5 solutions. And up here, our highest exponent is 5. That's one way to check to see if you've done it right or reduced far enough, is you should end up with the same amount or the no solutions for that amount that add to the total. Up here, we had 3, 1, 2, 3. Here we had a 4, 1, 2, 3, and we talked about how the 0 would have been 2 of them. So that is 6, 7 with the end of chapter 6. Let me know if you have any questions.